Well, Algebra 2, we're going to continue on with the common base to solve certain problems. And the reason why we call it the common base is because that's my whole goal, is the word common means the same. You know, think about if you have a friend and you say that we have a lot in common. We have a lot that is the same. So what you have to do is think strategically about getting the same base on both sides. Now, here's my hint for anybody that knows what a prime number is, that you can't change a prime number. 2 is a prime number. Its only factors are 1 and 2. So chances are you have to change 16 to be a base of 2. And then you can guess and check. You can use your fingers. 2, 4, 8, 16. That took 4 2's to get there. But the whole point is, if the bases are the same, then the exponents must be the same. So x must equal 4. And right now it might seem silly that we're doing this, but we're going to lead up to something big. 3 is another prime number. And think about how 27 is 3 to the third power, 3 times 3 times 3. So therefore, the x value must be 3. And I have no problems if you're using a calculator. I'm going to bring up a calculator. That if you don't know that 5 to the negative second power, okay, well, you might have to hit the fraction key and change it to a fraction. Sorry, math key to change to a fraction. Hit enter, and you can see that it's 1 over 25. So I have no problems if you're going to guess and check, but what you ultimately need to be able to do is think about, okay, well, we have another prime number. 5 is prime. And think about, well, how do I get negative exponents? How do I get fractions with negative exponents? And 5 squared, 5 times 5 is 25. And the reason why I think that'll help you is when you get to the next one. Now, 4 is not a prime number, but I'm going to leave it as 4 to the first, because I know that 16 is the same thing as 4 squared. And so the thought process is, okay, a power to a power, you can multiply those exponents. 2x will equal 1, and then you can divide both sides by 2. And you know me, I prefer the fraction answer, x equals 1/2. And the reason why that should be helpful is I don't know how many of you would go to a calculator and just guess that 16 to the 1/2 power is equal to 4, but it is. And it's only going to get more difficult from here. Here's another situation where we're practicing a power to a power. We're going to multiply those exponents. Now, some of them are really, really straightforward, really easy. Like this first one, just leave it as 2 to the 3x. I don't want to see, I guess if you really wanted to, you could rewrite this as 8 to the x power, but you're defeating the purpose of what I'm trying to get you to learn. So that's why I don't really care to see that. Like this next one, yeah, 3 squared is 9. But what I want to see is that you're practicing a power to a power, you're multiplying those exponents. Now, another reason why I want you to do that is because when you get to a problem like this one, you have to distribute, because it's multiplication. And you distribute multiplication into an addition or subtraction problem. So the answer I'm looking for in this one is 5 to the negative 3x plus 7, because negative 1 times negative 7 is a positive 7. And then just to finish up my thought process, this other one will be negative 3 plus 3x squared. So as I move on to the next example, I don't know how many of you would be able to just look at these problems and guess what the power needs to be. So the thought process is to get the same base. We call it the common base. But I know, well, I shouldn't say I know, but I have a feeling that you guys are better with the word same than you are common. So after a lot of thinking, and it does take some time to think of it, is the common base between these two is 2. 2 cubed is 8. 2 times 2 times 2. And it's, a power to a power. You multiply those exponents. And then that would be 2 to the 5th power. And the whole thought process now is the bases are the same. So 3x must be equal to 5. And I like fractions. Then I'm going to leave this answer as 5/3. Just kind of a heads up. If you change that to a decimal, I will probably give you full points. But if you check your work and you type it in as a fraction, 8 to the 5/3 power, you actually get the exact value of 32. Because I've had students in the past, like they'll go up and grab that and they'll type it in and they'll think they're wrong because it's rounding answers. But yeah, 5/3 is a perfect answer. And like I said, it's going to take you some time to figure this out. You know, can you just look at this and say, oh yeah, 3 squared is 9 and 3 cubed is 27? Well, maybe before getting the same base, you should also distribute that 2 into the problem. And then from here say, okay, well now I know that my exponents are the same. My bases are the same, so my exponents need to be the same. Subtract 2 over. Kind of running out of room, but you know me, I'm going to leave this as a fraction, but that is 0.25. And you can check your work because I can type that into a calculator. 9 to the 2 times 1/4 plus 1 power gives me the correct answer of 27. So every answer that we get should make sense. Just moving on to the next one. And I know I'm probably moving fast, but remember you can pause the video and you can rewrite it. 5 cubed is 125. 5 to the negative second power is 1/25. We actually did that earlier. But remember, you need to distribute. And I have no problems if you do a couple steps at the same time. Like the bases are the same, set the exponents equal. And while you're setting the exponents equal, go ahead and distribute that -2. So at this point, I would probably just subtract 2x to the left side. So we're looking at 1x is equal to -8. Now this one's a little bit trickier to check your work because if you go to a calculator and you type in 125 to the -1/8 power, okay, it's kind of an ugly decimal, but if you then make 1/25 to the 4 minus, whoops, I put in the wrong answer, didn't I? Let me fix that. There you go. You can see that they're the same decimal. I had a feeling I did something wrong, but there we go, I fixed it. So you have to type in -8 on both sides and see that you get the same decimal on both. So moving on to the next one, it's not much different. Again, feel free to use a calculator. I'll let you use a calculator. If you didn't know that 2 to the 6th power is equal to 64. You know, you could even write that out. I'll even change colors. That's 2 to the 6th power. And the thought process is the bases are the same, so the exponents must be the same. Add 3 over. And then when you square root both sides, remember, you get a positive and negative version of the correct answer. There you go. So again, if I explain that very quickly, you might want to hit pause in the video, think about it, write down your questions, and come back to me. And I think at this point I might be done checking my answers on a graphing calculator, but I mean, we'll see. Because on this one, think about it, that 5 squared, let me write it over here, is 25. But when you go to do this, you have to make sure that you distribute. At the same time, 5 cubed is 125. But again, you need to distribute. So I'm going to distribute and drop the bases. And if that's not making sense, make sure you write down those questions. Because at this point, what I would do is subtract 3x to the left side and add 6 to the left side. And now you can slide and divide, or your quadratic formula. All those things that we've done earlier in the year are coming back for you. If you're a slide and divide fan, that's 2 times 6 is 12. And 1 and 12 will make them both negative. And then don't forget to divide by this 2. So we're looking at that factors out to be 2x minus 1, as well as, well, 12 divided by 2 is 6. And at this point, we can use the zero product property. Remember ZPP, or zero product law. So we'll get x equals 1/2, or x equals 6. And as far as checking your work with the table on your graphing calculator, I guess it would be worth the time to do that. That if you typed into y equals both equations, 25 to the x squared, can't see it, minus 5x power, and then go down 125 to the x minus 2 power. And if I go to my table, what will happen is if I look at the x equals 6, I get the same value, whatever that giant number is. And the downside is I can't quite see at x equals 1/2. But if you hit second window, you can change your graph settings to count by 0.5s. So now if I go back to my table and look at x equals 0.5, now I do get the same decimal on both of those, where everything else is off. So kind of tricky to check that out. Second window is how you change your table setting, and then you can get the right answer. Now this next one, I knew that at some point this was going to happen, that we haven't quite done cosine. I knew I skipped a section, so we're going to have to skip these problems. I'll look in the homework to see if any of these show up again. But we can definitely do exercise 7, where I could rewrite this problem as 6 squared, but 6 times to the 2 root x power, and then 6 to the 3rd power. If you didn't know that, you can double check with the calculator. That 6 to the 3rd power is 216. And then the thought process is that 2 root x is equal to 3. So what I would do is just divide that 2 over, and then to solve a square root problem, you can square both sides. Just make sure that you square both the top and the bottom to get 9/4. Okay. There's a reason why I skipped exercise 6, but just so I have good notes, I'm going to go ahead and do this. If you've learned this before, that you could still do 3 squared is 9, and then 3 to the 1st power, and then the whole thought process on this is that 2 cosine of theta is equal to 1. So cosine of theta is equal to 1/2. And if you've learned the unit circle, if you haven't, then you can't really do this problem. But at 1/2 would be up here. To think for a second, that would be 1/2 root 3 over 2. But it happens again over here at 1/2 negative root 3 over 2. And those two angles would be 60 degrees as well as 300 degrees. Let's see. So in our homework, I wonder if there's any more of those theta problems. Yep. So we're going to have to remove question 5, but everything else looks fine.